Okay. In networking, what we are going to have a look at is virtual private cloud or VPC. Okay. We have VPC sizing or subnetting. We have seen a little bit of subnetting or the CIDR yesterday. It was a bit probably must have been confusing, but we'll try to simplify that. And VPC subnets, public and private subnets. We have different types of subnet inside of VPC or a virtual private cloud. And we have the different networking components in AWS, such as the internet gateway, the route table. Well, not necessarily the route table, but the router itself, the implicit router, which we use route table to configure it. Network access control list, security groups, and NAT gateways as well. So these are the different types of networking components in AWS networking. Okay. So let's start off this topic with Amazon VPC or virtual private cloud. This is the abbreviation of virtual private cloud. Okay, the pen is going crazy again. All right. So, a logically isolated virtual network you define to launch AWS resources such as EC2 instances, databases, and so on. So, logically isolated virtual network. Okay, so this is something that you define. You would create a VPC or a virtual private cloud because you need to deploy your resources inside that virtual private cloud or that isolation. Okay, and VPC closely resembles to a traditional network data center. Okay, let's take this example. So you are in your home, office, or some sort of network, and you get a couple of or three devices. Maybe you get some switches, you get some routers, and then you connect different types of devices over here. You have some computers over here interconnected with one another. Okay. For this example, assume you are not using any kind of ISP. You're not letting traffic go to the internet. Okay, you don't have anything of that sort. So for a person to have access to these resources that you have, maybe you have seen some sensitive data over here. For somebody to access that, that person has to be physically inside that room in order to access this. So this is your physical isolation or physical boundary. And VPC or virtual private cloud is a logical isolation or a logical isolation or a virtual network. Okay, where you deploy your resources, such as EC2 instances, databases, and so on. Okay, so here's your VPC, and your VPC can span multiple availability zones. We said that we need to utilize multiple availability zone when we deploy our EC2 instances so that we can have high availability, because in case one availability goes down, so that we can have other EC2 instances that will run on other availability zones. So when you deploy your VPC, when you choose a region, there is a process to that. Anyway, your VPC has to span multiple availability zone. You just don't want your VPC in a single availability zone because it's too risky. It means that you're not highly available. Okay. So it spans multiple availability zone, and a VPC stays within a region. Okay, a VPC cannot bleed through other regions. Say, for example, if this is a London region, this flag represents the region. A VPC will stay, whatever VPC you define, it stays inside the region. It cannot bleed through another. Maybe you have a Frankfurt region over here, it does not pass. It cannot go to Frankfurt region. It stays within a region. Okay? So that is what a VPC or a virtual private cloud is. And then inside this VPC and inside this availability zones is where you deploy your EC2 instance, your virtual servers, your database, and so on by creating subnets. Okay, so you have to create subnets in order to deploy your resources. Okay, so this is what a VPC is. It allows you to customize access control, access control to your resources, allow or deny traffic. Okay, so you have your VPC here. This is your isolation, the same as the physical on-premises. So if you want, you can call an ISP. It could be any ISP, Vodafone or any ISP, and then you can tell them to give you internet access, and they will put a device here, an edge device. It could be a router, it could be a modem, whatever it is, and they'll give you access to the internet so that you can go out and speak to the internet to have access, and maybe someone can have access to your applications over here. In that same way, VPC gives you control. Okay, so if you want some people to access, maybe this is a web application, maybe you have deployed it for the public, and this is your database. Obviously, you don't want your database people to access your database. It's a huge security vulnerability, right? You want to keep this private. So in order for the people to access your web's applications, your web servers, you can attach what's known as the Internet Gateway, or IGW, so that people will have access, and your EC2 instance can have access in and out to the internet. So Internet Gateway, as name indicates, will provide you access to the internet. But there's a way we can have this very secure. Even though we have an internet gateway, we can put this in a private subnet so that it will not be accessed, because it's a database. We'll have a very detailed look on that. Okay, that's cool. So VPC classes interdomain routing. Okay, here we go again. We have come to the CIDR notations. Okay, CIDR classless interdomain routing is used to define an IP address block for a VPC. The same way as we did in the on-premise environment, we have to assign a certain address block to our VPC, because our resources, they would need an IP address at least to communicate with one another. And if we want our EC2 instance or virtual servers to communicate with the internet, our resources or servers will need a public IP address, because private IP address cannot be routed on the internet. All right. So anyway, the CIDR that we allocate to our VPC is usually a private. Usually, most of the time, private IP. Okay. So the most common one you'll find is probably 172.16.0.0/16, or 31 or 32.0, whatever it is, to our VPC. Okay. The allocated CIDR block is divided into subnets for organizing and deploying resources across availability zones. So we do have to create subnets in order to deploy our resources, EC2 instances, database, and so on. Okay, VPC CIDR blocks can range from /16 up to /28. In AWS VPC, anything less than /16 is not going to work. There is no /15, there is no /14, there is no /8, and so on. The minimum that you can go is the /16, which will give you a lot of IP addresses, and the highest number of the slash, which will give you very few IP addresses. The largest one is /28. You cannot do /29, /30, up to 32. You cannot. The maximum is 28, and the rest are reserved by AWS. So it would look something like this: 1, 2, 3, 4, 5, 6, 7, 8.8, and here you have some room to play around, and the /28, I think 4 zeros are going to be reserved as well. So this part is reserved and this part is reserved. You cannot touch it, but you can create subnets, you can create bits of host bits and so on among this range. Okay, just remember this /16 and /28. Okay, in the real world, not necessarily in the cloud, when we deal with networking, the first IP address is the network address. We cannot allocate it to a device or to a computer. And the last IP address is the broadcast address, and it cannot be allocated to a device, okay, in a simple network. Okay, and in AWS, we do have 5 reserved IP addresses. Outside of AWS, we have 2, the network address and the broadcast address. Okay, but in AWS, we have, of course, the first one. For example, if we take this 172.31.0.0/16, the 172.31.0.0, this is the first IP address. This is the network address, okay, because these are all ones. This is the /16, so you cannot allocate this. It's a network address. 172.31.0, the first IP address is reserved for the VPC router. The second IP address, the 0.2, is reserved for VPC DNS server. We have a DNS server inside our VPC. Remember that. And 172.31.0.3, this is just simply for future use. And the last IP address, the 255, is the broadcast address. So this one and this one as like in the real world scenario, but this and this, the rest is reserved for AWS purpose. Okay, remember this one when we talk about VPC. This applies for each subnet we create. Okay, doesn't matter. So VPC CIDR, this is how we do it. So we have our region. This is US West 1, as we taken as an example. And we have our VPC that is spanning multiple availability zones, 1A, 1B, and 1C. This, we refer this as ASIS, okay? These are the ASIS. This is how it's drawn, usually. This yellow thing, this is our VPC, okay? And the black or maybe some greenish thing, this is our region. Okay, so we can see that the VPC stays within a region and it spans multiple availability zones. Okay, so what we do here is we allocate a CIDR block or a range of IP address to our VPC. In this case, 10.0.0/16. Okay, and we create subnets so that we can deploy our resources. Now we did a subnetting, and then we came up with a /20. Okay, so this is a chunk or a small portion of this larger network. The 16 is a big network, but we are subdividing the 16 into chunks of subnets and chunks of networks so that we can deploy our resources there. So this is one network, 10.1.0.0, and the next is 10.1.16.0, the next is 32, next is 48, 64. So these are different networking. If you are curious, we can have one extra time. So if you want to know how to do subnetting, but for now, let's just have a look at this as it is. Okay, so we created different subnets in different AWS availability zones. And so now we are making all the use of all the availability zones that we have. And we can deploy our resources in this subnet. So we can deploy some resource over here. Maybe we can deploy our database over here on this subnet and so on. After creating this infrastructure is where we can deploy our servers and databases and so on.